October 24th, 2025. A quiet day, or so it seemed. The air over the Pacific was calm, the stars serene, but far above that stillness, something stirred. Military satellites blinked awake, one after another, as if some silent command had passed between them. And so, the question that hums beneath the static: if 3I Atlas is harmless, why does the world act as if war is coming? You see, this isn't just about a comet, it's about a visitor. An interstellar traveler, cutting through our solar system like a ghost through a cathedral. We've seen them before: Oumuamua in 2017, Borisov in 2019, each one changing how we think about what drifts between the stars. But this one, well, this one feels different. Perhaps it's the silence. Perhaps it's the way the instruments whisper, the way the officials avoid questions, or the way our own curiosity trembles before the unknown. Because every time we meet a stranger from beyond, it's not just the object we study, it's ourselves. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. And while you're here, where are you on the map? Let me know where you are in the world and what time it is as you're listening. It's always fascinating to see who's joining us from all around the world. So let's continue. Chapter 1 unfolds in the dim glow of radar screens and the quiet hum of observatories across the world. In the early hours of October 24th, 2025, the International Asteroid Warning Network, IAWN, issued a discreet message to its global partners. No alarm, no press release, just a short transmission. It was the kind of message that only astronomers and defense analysts would notice. And yet, within minutes, it began to ripple outward. Something new had entered the solar system. Its orbit was confirmed to be hyperbolic, which meant, quite simply, that it did not belong here. It had come from the vast gulf between the stars, moving faster than any comet naturally bound to the Sunday. For scientists, this was cause for fascination. For the military, it was cause for alert. The IAWN had a protocol called the Astrometry Campaign, designed to refine the trajectory of objects that pass near Earth. Usually, it involves university telescopes, amateurs, space agencies, a network of quiet cooperation. But this time, the network behaved differently. Within hours, data from civilian observatories began to disappear from public databases. Astronomers who had tracked the visitor found their servers suddenly restricted, and in their place, new observation coordinates were issued classified under a planetary defense initiative. That phrase, planetary defense, carries a weight it rarely deserves. It is meant for asteroids on collision courses, for those 1 in a million chances that demand attention. But 3I Atlas, as it was designated, posed no threat of impact. Its path was elegant, distant, almost leisurely. So why the secrecy? Why the sudden choreography of nations moving in unison, as if rehearsing for something they could not yet name? Well, you see, it starts with how the sky is watched. Every night, dozens of telescopes scan the heavens, tracking rocks and comets, sending their data to central servers. But when a new object moves too fast, when its brightness shifts in unpredictable ways, the algorithms flag it as anomalous. 3I Atlas triggered every anomaly filter within hours of its discovery. Not because it was dangerous, but because it was strange. Its brightness fluctuated, not like dust reflecting sunlight, but like metal catching it. The radar echo was faint but sharp, as if bouncing off a surface smoother than ice. The calculations showed an incoming speed of 61 kilometers per second, nearly twice the velocity of the fastest comets we know. It was not falling toward the sun, it was merely passing by, untouched, like a silent messenger crossing a crowded room. And yet, almost immediately, the quiet machinery of global defense stirred. The United States Space Command redirected 2 surveillance satellites to track the object's thermal signature. The European Space Agency repositioned its deep space network dishes. The Japanese radar array in Uzuda received instructions to allocate observation time for an unspecified interstellar target. No one said the word, but everyone understood this was not just a scientific event. It was a test. Perhaps that's the most revealing part, the coordination. These systems are not designed to cooperate so smoothly. They belong to agencies with different priorities, different languages, different thresholds for secrecy. But here, they moved as one, as if a hidden conductor had lifted a baton somewhere behind the curtain of international space policy. When the data began to flow, something else happened. The signals were encrypted. Even public telescopes, those funded by universities, received temporary operational requests to withhold their images. The justification was subtle, to prevent misinterpretation of early data. But to many astronomers, it felt like déjà vu. They remembered the silence that followed the discovery of Oumuamua years before, the long gaps between statements, the careful wording, and now it was happening again. I suppose that's the nature of uncertainty. When the unknown approaches, we wrap it in silence, as if secrecy could make it safer. But in doing so, we often reveal our fear more clearly than any telescope ever could. Down at the Jet Propulsion Laboratory, a small team analyzed the preliminary orbit. The numbers traced a path that cut neatly through the ecliptic plane, the thin disk where most planets orbit. For an interstellar object, that was statistically improbable. It suggested intent, or at least precision. Most visitors from beyond the solar system arrive at random angles, like pebbles skipping across a pond. But this one seemed to glide exactly where it would draw the most attention. A young engineer reportedly muttered, "It's too perfect." Her voice wasn't recorded, but the comment made its way through the grapevine, whispered across Slack channels and encrypted chats. Too perfect. The kind of orbit that would make you wonder whether chance was really in charge. Meanwhile, the International Asteroid Warning Network continued its campaign. Observatories in Chile, South Africa, and Hawaii pointed their instruments skyward. Spectrometers began to analyze the faint light reflected from the object. Normally, such readings would be released instantly, shared across scientific databases. Instead, they were tagged as preliminary, pending verification. The verification, however, never seemed to arrive, and that's when rumors began to surface. Some claimed the object had shown unusual emissions, radio signals perhaps, or modulated light. Others said its rotation period was inconsistent with its shape. Most of these were conjecture, built on the thin scaffolding of leaked data and speculation. But amid the noise, one fact held steady. The world's defense apparatus was treating 3I Atlas as a live exercise. Perhaps it was all coincidence. After all, governments often use real-world events to test their readiness. But to those who had spent their lives watching the sky, it felt different this time. The tempo was off, the messages too synchronized, the silence too deliberate. Across continents, observatories fell under new communication guidelines. Data relays were rerouted through centralized nodes. In Washington, a briefing document described the event as a planetary coordination scenario. The tone was procedural, detached, but beneath the language lay something more primal, the instinct to prepare. There is, an old saying among astronomers, the first object we don't understand will tell us more about ourselves than about the cosmos. And as 3I Atlas approached, that saying felt truer than ever. Because the reactions unfolding on Earth were no longer about discovery, they were about control. Even within the scientific community, tension grew. Some researchers protested the lockdown, arguing that open data is the foundation of trust. Others defended the caution, reminding everyone of the chaos that follows when speculation outruns evidence. But both sides missed the deeper question, Why did the world's defense infrastructure activate for something that posed no physical threat? To understand that, you must look at the shadows of precedent. In 2008, a small asteroid named TC3 was detected just hours before impact. It burned over the Nubian desert, harmless but historic, the first time humanity had predicted and confirmed a cosmic collision. That event triggered a protocol, a chain of readiness drills that linked civilian science to military awareness. The idea was to ensure rapid response to any potential threat. But now, years later, those same circuits had come alive for an object that everyone agreed would never touch Earth. So perhaps this wasn't defense, perhaps it was demonstration. In the control rooms of Colorado Springs, in the quiet halls of Darmstadt, in the humid night air of the Canary Islands, people watched screens glowing with numbers. Every few minutes, the position of 3I Atlas updated. The data lined up neatly, almost beautifully, a curve through the darkness, a whisper through time. Outside, the world went on as usual. Children went to school, cities glowed beneath the same indifferent stars, and yet, above it all, a choreography played out a global rehearsal for a future no one had yet defined. You might imagine that those involved felt excitement, even pride. But the truth, according to those who later spoke anonymously, was closer to unease. They weren't sure what they were defending against. They only knew that someone, somewhere, had decided this was more than a comet. By the second night, the object's brightness increased unexpectedly. Some instruments recorded faint variations, as if jets of gas or dust were pushing against sunlight, but at its distance, 3.5 astronomical units from the Sun, such activity made little sense. Too cold, too dim, too far for ice to sublimate. Yet the data insisted otherwise. And that's when the real question began to form. What if this visitor behaved like a comet, but wasn't one at all? Reports circulated quietly among specialists. A few suggested that the outgassing patterns were uneven, not radiating from a natural surface, but from points localized, discrete. It might mean nothing. It might mean everything. But in the absence of explanation, speculation grew like frost over glass. Meanwhile, communications between agencies tightened. Public briefings were postponed. And in the vacuum of information, a different kind of noise began to rise, the sound of curiosity turning to suspicion. Somewhere in that growing tension, a few scientists began to ask a quieter question, the kind that never makes headlines. If this really is harmless, why does everyone act as though it isn't? The days that followed would only deepen that mystery, as new measurements revealed a brightness curve unlike any known comet, and as whispers of metallic dust began to appear in the spectral data. But that leads us into the next part of the story, where light itself begins to speak. The numbers began to take shape on screens around the world, columns of figures, curves of light, lines that told a story only a few could read. 3I Atlas, the visitor from beyond, was now close enough for astronomers to map its path through the solar system. It was a path both simple and unsettling. Its orbit, unmistakably hyperbolic, told us that it came from interstellar space and that it would never return. It was not a prisoner of the Sunday, it was merely passing through. For most comets, gravity is a leash. They fall inward, loop around, and drift back to the cold. But a hyperbolic trajectory is something else entirely. It means freedom. It means velocity too great for the sun's pull to restrain. In numbers, that speed was 61 kilometers per second faster than any known comet, faster even than Voyager 1, humanity's farthest messenger. You might say it was moving at the speed of indifference, untouched by our star's authority. When astronomers plotted its curve, they noticed something curious. The path of 3I Atlas was almost aligned with the ecliptic, the thin plane where planets orbit. For a random visitor from the interstellar deep, that alignment was extraordinarily unlikely. Imagine throwing a pebble across a spinning dinner plate from miles away and watching it skim perfectly along the surface. The odds of such precision were almost poetic. Perhaps that is why some began to whisper that its orbit was beautiful in a way nature seldom is, too elegant, too deliberate. In the language of mathematics, beauty often hides intent. And though no scientist would ever admit to believing in cosmic intention, the thought lingered, like a spark beneath the ash of reason. At the European Southern Observatory, a team began reconstructing its three-dimensional trajectory. They overlaid it against models of the Milky Way's local stellar neighborhood, tracing where it might have come from. The model suggested an origin point somewhere in the constellation Lyra, though the uncertainty was vast. Lyra, the harp of the heavens, home to Vega, one of the brightest stars we know. It was tempting, almost romantic, to imagine the object as a note from that cosmic instrument, crossing the darkness to reach us. And yet, beyond the poetry, the physics remained relentless. To travel from the nearest star at that speed would take nearly 1,000,000 years. Whatever this thing was, it had been moving long before humanity learned to stand upright. It had crossed the dust lanes of the galaxy, drifted past invisible suns, perhaps even through the faint glow of ancient supernovae. The fact that it arrived here, now, when our species had the eyes to see it, that coincidence alone was enough to make even the most grounded scientist pause. Some wondered if it might be related to Oumuamua, the first interstellar visitor discovered 8 years before. Oumuamua had been silent, tumbling oddly, reflecting light in flashes that hinted at flatness, at shape, at something not quite natural. 3I Atlas, by contrast, wore the cloak of a comet, glowing, diffuse, a shroud of gas and dust. But beneath that veil, there was a familiar rhythm, an echo of that first enigma. You see, when astronomers track comets, they expect certain patterns of motion. The jets of vapor that erupt from their icy surfaces push them slightly, altering their course in ways that can be predicted. But 3I Atlas resisted those patterns. Its movement was too steady, as though guided not by chance but by design. The gravitational model fit perfectly, almost unnervingly so, as if someone had drawn it rather than discovered it. Perhaps this is where the unease truly began. When an orbit looks too precise, scientists become suspicious. Nature is messy. Chaos leaves fingerprints. But 3I Atlas traced a line of such quiet order that some began to call it, half in jest, the clockwork comet. In mission control rooms and university offices, people stared at the simulations. The object's path through the inner solar system would take it within a few astronomical units of Earth, not close enough to pose danger, but close enough to study. For weeks, the world's most powerful telescopes trained their lenses upon it, and as the data accumulated, a strange duality emerged. From a distance, it behaved like a comet. Its coma, the glowing envelope of dust, flared with sunlight. Its tail stretched faintly across the black. Yet the core, the nucleus at its heart, remained elusive. No rotation pattern could be established. It was as though the object refused to spin, or spun so slowly that no human instrument could tell. That too was unusual. Every comet we know spins, that motion is written into their creation, but this one seemed to hover in quiet equilibrium. There was another detail that unsettled researchers. The tail of 3I Atlas did not fan out from a single axis. Instead, it appeared bifurcated, as if light were scattering off two distinct regions rather than one. When the data were plotted, the angles formed a near-perfect symmetry, a mirrored geometry no one expected. Again, too neat, too intentional. At a press conference in Geneva, a senior astronomer described it cautiously as an unusually stable trajectory. She smiled, as scientists often do when faced with mystery, but the unease was visible in her eyes. Behind the words stable and unusual, a different thought flickered. What if we were watching something built, not born? Still, the official explanation remained conservative. It was, after all, safer to call it a comet. The word has history, comfort, a lineage of familiarity stretching back to ancient skies. A comet can be studied, measured, understood. But a visitor, an interstellar traveler that invites a different kind of wonder, one that science is not always ready to confront. At NASA's Center for Near-Earth Object Studies, analysts compared its trajectory to historical records. There was no match, no periodicity. It was the first of its kind in both shape and direction. Curiously, its incoming vector, its approach from above the plane of the solar system, was almost identical to the path along which several human-made probes had been launched decades ago. Not close. Enough to imply connection, but close enough to whisper coincidence. Perhaps it was nothing. But when coincidences begin to stack upon themselves, they start to resemble design. Meanwhile, artists and journalists began to fill the gaps that data would not. They imagined the object as a dark mirror, an ancient arc of frozen material from another star. Some called it a messenger, others a warning. And though the scientific community tried to stay grounded, the metaphor was difficult to escape. Because in its silence, 3i Atlas seemed to be watching us back. From a purely orbital perspective, there was no reason for alarm. Its perihelion, the closest point to the Sun, would occur far beyond the orbit of Mars. But from a psychological perspective, the timing felt uncanny. Humanity, in the early years of the third decade, had learned to scan the skies for threats. Every new detection was framed as potential danger, every anomaly a headline, and so, as the object glided inward, the language surrounding it darkened. Words like monitoring, preparedness, and defense readiness appeared more often than discovery. You might think that numbers can protect us from fear, but sometimes numbers deepen it. When scientists plotted the probability map of 3i Atlas's possible trajectories, the result was a narrow thread of certainty. It would pass safely, but its path brushed near the gravitational influence of several planets in a way that seemed orchestrated like a spacecraft, using slingshots for efficiency. To those who saw the resemblance, it was both thrilling and terrifying. The notion that something could traverse interstellar space, and then, by chance, weave so gracefully through our planetary system, was difficult to accept. The probability of that precision was vanishingly small. And yet, here it was, unfolding before our telescopes, serene and silent. In the quiet halls of the Institute for Astronomy in Cambridge, a researcher once described the orbit as a mathematical sonnet. It was, she said, as if the universe had composed a poem in motion, each gravitational note landing exactly where it must. The irony, of course, is that the more perfectly the data fit, the less human minds trusted it. Perfection, in nature, is a stranger's accent. It sounds almost right, but not quite native. And that brings us to the question that lingers like static in every analysis. Can a trajectory be a message? For now, the official records describe 3i Atlas as a natural body, an emissary of cosmic chance. But in the coffee-fueled conversations of late-night observatories, people spoke differently. They spoke of intent hidden in motion, of geometry as language, of the possibility that every orbit tells a story, if only we learn how to listen. As the object moved closer to the inner solar system, sunlight began to touch its surface with greater warmth. Telescopes captured a faint increase in brightness, followed by a sudden bloom of reflected light that no one could quite explain. It was not violent, not explosive, just a breath, as if the visitor had exhaled for the first time. And from that exhale came something stranger still, the spectral signature of gases that should not exist at that distance, at that temperature. Scientists would later call it the outgassing anomaly. But at the time, no one yet knew that this simple breath of vapor would unravel the very definition of what a comet could be. And so, as 3i Atlas began to shine more brightly against the velvet of the sky the story deepened. The world had already questioned its path, its origin, its perfection. Now it would begin to question its very nature. It began with a shimmer, barely perceptible at first, a subtle brightening that every instrument saw, but no one could explain. 3. Atlas, the interstellar traveler that had so far glided through the void in silence, had begun to breathe. At 3.5 astronomical units from the Sun, well beyond the orbit of Mars, it started releasing gas and dust as though it were a living thing stirred from slumber. The event was unexpected. At that distance, sunlight is too weak to warm even the most volatile ices. Any ordinary comet would remain frozen, inert, its gases locked away beneath a crust colder than Antarctica's heart. And yet, this one stirred. To the scientists watching, it was a contradiction written in light. On the spectral charts, faint emission lines appeared: carbon dioxide, carbon monoxide, a whisper of water vapor, but the ratios were impossible. Normally, comets are dominated by water ice, with trace amounts of other molecules, but 3I Atlas defied that rule. Observations from the James Webb Space Telescope revealed something astonishing. The proportion of carbon dioxide to water was nearly 8-1. It was a chemistry out of balance, as though it had been formed in an environment entirely alien to our own solar nursery. The data puzzled chemists. You see, in the outer reaches of our system, beyond Neptune, the sun's warmth is so faint that water freezes solid while carbon dioxide can escape easily. Comets formed, they are rich in water. But for one to contain this much carbon dioxide, it must have been forged in a place where temperatures were so low and radiation so fierce that only the most volatile compounds survived. Perhaps near a dying star, or in the shadow of a supernova's ashes, or perhaps, as one researcher dared to suggest, in the exhaust of something not entirely natural. At first, such thoughts were dismissed as romantic speculation. Science, after all, is built on restraint, but the numbers would not behave. The more data the Webb telescope gathered, the stranger the profile became. The light curve oscillated in irregular intervals, as though pockets of gas were venting from beneath a sealed crust. Each burst increased its brightness slightly, then faded into quiet. It was, in a way, like watching. A pulse, steady, rhythmic, almost deliberate. In the control room, an engineer stared at the screen and muttered, half to himself, "It's breathing." The words were meant as metaphor, but they lingered. Because the object's behavior mirrored something organic, a system responding to warmth, releasing energy in cycles, adjusting to the environment. Comets are supposed to be chaotic when they outgas, their jets firing in random directions, but 3I Atlas was measured, controlled. Each plume erupted from nearly the same coordinates, as if from engineered vents rather than natural fractures, and that pattern raised questions no one was eager to voice aloud. The team at the European Space Operations Centre ran thermodynamic simulations to test whether such behaviour could be explained by known materials. None fit. The only model that matched the observed venting rate required a layer of dust mixed with metallic compounds, forming an insulating shell that could trap heat beneath it until pressure built enough to escape in bursts. That composition, metallic and carbon-rich, was something we had seen only in industrial byproducts, never in celestial bodies. The astronomers, careful as always, phrased their findings gently. They called it thermochemical peculiarity, but beneath that sterile label, a quiet sense of wonder spread. What kind of place could forge such a body? What kind of process could shape matter so fine-tuned that it disobeyed the simple laws of thermal physics? As days turned to weeks, 3I Atlas approached perihelion, the point closest to the Sunday. Its coma brightened, expanding into a faint emerald halo. Through telescopes, it looked almost serene, a green flame adrift in the dark. Yet the spectrographs told another story. Embedded within that glow was a strange absence. The spectral lines, corresponding to water vapor, were weaker than they should have been, while the signature of carbon monoxide spiked sharply. It was as if the object were shedding its lighter molecules, leaving behind a residue of heavier, more complex gases. At the University of Arizona, a group of planetary scientists compared these readings to known cometary data. They found no match, none. Even the interstellar comet Borisov, once hailed as the benchmark for comparison, had shown a far more conventional composition. 3. Atlas stood alone, chemically exiled from every catalogued object in the solar archive. And yet, the deeper mystery was not its composition, but its timing. The eruptions were too periodic to be random. Roughly every 19 hours, a pulse of carbon monoxide vented into space, consistent enough to form a measurable pattern. When mapped, those pulses aligned with the object's faint rotational hints, suggesting a slow, deliberate spin. The ratio of intervals was almost harmonic, a mechanical rhythm hidden within cosmic noise. I suppose it was around that point that the mood began to shift from curiosity to something else, an uneasy respect, perhaps, or a quiet awe, because this was not chaos, this was choreography. You see, comets are messy storytellers. They tumble, crack, flare and fade without pattern. They are ancient fossils, fragments of frozen time. But 3I Atlas behaved as though it remembered something, as though some order had been written into its structure long before it entered our sky. There were theories, of course. Some suggested it had once belonged to a planetary system orbiting a dying red dwarf, where prolonged exposure to radiation could have altered its chemistry. Others speculated that it might be the remnant of a world's atmosphere, frozen and expelled into the void after a stellar cataclysm. These ideas were bold but still natural. Yet behind closed doors, a handful of scientists began to explore a more radical possibility, that its outgassing might not be natural venting at all, that it might, in fact, be the decay of materials once engineered. Imagine, they said, a structure adrift for millions of years, a shell of carbon composites, once part of a machine, now eroded by interstellar dust. Over time, its surface oxidizes, its volatile compounds trapped within microscopic chambers. When sunlight reaches it again, those chambers release their contents in controlled bursts. To us, it would look like outgassing. To them, perhaps, it was once propulsion. The notion bordered on heresy, but it refused to die. Especially when one final anomaly appeared. The emission spectra showed faint traces of nickel and magnesium metals rarely found in comets, and never in such proportion. The nickel, in particular, was puzzling. It suggested temperatures of formation far higher than the icy domains of space could provide. Some likened it to the residue left by meteoritic cores, others to alloys. The story reached the desks of those beyond academia. Within days, several observatories were instructed to classify their findings. Access to spectral databases was quietly restricted. Public discussion threads vanished overnight. Officially, the reason was to prevent premature interpretation. Unofficially, it was because the data hinted at something that unsettled the comfortable line between science and imagination. And still, the telescopes watched. In the dark hours before dawn, astronomers in Chile recorded high-resolution images of the comet's coma dispersing. They noticed something strange about the way sunlight scattered through the dust. The polarization pattern was inverted. Normally, light reflected from cometary dust becomes polarized in a predictable direction, revealing the grain structure of its particles. But 3I Atlas showed what researchers called negative polarization, an optical reversal so rare that only a few exotic materials could produce it. At first, they suspected instrument error. They recalibrated, retested, waited. The pattern persisted. Negative polarization meant the dust grains were either metallic or layered in a way that scattered light back upon itself. Carbon nanotube analogues could do that, so could microstructured films, the kind used in advanced optics. But not the random debris of ice and rock. One astronomer, exhausted after 40 hours without rest, simply stared at the graph and whispered, "It's like dust from a furnace." That image lingered, the thought of dust forged, not born, drifting through interstellar space until it found us. By mid-November, the media had caught fragments of the story. Official agencies dismissed the wilder interpretations, assuring the public that everything observed was within the expected range of cometary behavior. But those who had seen the raw data knew better. The object's chemistry was beyond expectation. Its geometry defied randomness, and its silence, its steady, unchanging radio quiet, only deepened the sense that something deliberate was at play. As the visitor moved further inward, closer to the warmth of the inner system, the brightness peaked once more. Observers noted a peculiar symmetry in the coma's shape, a twin spiral curling outward from its core. It was a breathtaking sight, beautiful, precise, unnervingly symmetrical, like two arms of a galaxy caught in miniature. And then, just as quickly as it had flared, it began to fade. The outgassing slowed, the halo dimmed, and 3I Atlas resumed its calm trajectory toward the edge of the sun's influence. But the silence it left behind was heavier than before. In those days, when scientists gathered to review their findings, conversations drifted from the scientific to the philosophical. What, they asked, makes something alive? Is it motion, reaction? Or is it memory, the ability to respond in patterned ways to the same warmth that once gave it purpose? If so, could this frozen traveler, pulsing with breath-like rhythms, be remembering something we cannot comprehend? No one had answers, only data, only the thin, silver line of evidence stretching through the darkness. But soon, a new mystery would rise from that same data, a strange reflection in the light itself. For when the polarization measurements were pushed to their limits, they revealed something that defied even the language of comets, something metallic perhaps, something made. And that, well, would change everything. The discovery of the polarization anomaly began quietly, almost by accident, as so many revelations in science often do. When the light from 3I Atlas reached the detectors of the VLT array in Chile, it carried with it a secret, hidden not in brightness, but in direction. You see, when sunlight bounces off dust, the waves of light twist slightly. They become polarized, and that subtle twist tells us what kind of surface they have touched. For ordinary comets, this polarization follows a familiar pattern, a gentle, positive curve that peaks near 30 degrees from the sunday. But the light reflected from 3I Atlas defied that pattern entirely. It was not positive, but strongly negative. To the untrained eye, that may sound trivial, but in the language of astrophysics, it is a whisper from the dust itself, saying, "I am not what you think I am." This phenomenon, extreme negative polarization, had only been seen a handful of times before, and never so strongly. It meant that the particles surrounding the comet were scattering light backward, toward the source, in a way that suggested metallicity or an ordered internal structure. In simpler terms, it meant the dust might not be dust at all. At first, the teams believed the instruments were at fault. They recalibrated, they compared against known standards, even cross-checked with other observatories. The results were consistent. Whatever surrounded 3I Atlas was composed of particles that behaved more like microscopic mirrors than grains of ice or carbon. And these mirrors, if one can call them, that seemed to have a remarkable ability to align themselves with the magnetic field of the solar wind. That alignment gave the light its strange twist, its negative polarization. The discovery rippled through the community, quiet but electric. In the data rooms where astrophysicists huddled over spectral graphs, a new phrase began to circulate: metallic dust hypothesis. It was not an accusation, merely an observation, an attempt to describe something that had never been seen in any natural comet. Some speculated that the dust was coated with nickel or iron compounds, perhaps the product of high-temperature condensation near another star. Others dared to suggest it might be something else entirely, a composite material, layered, designed to endure the violence of interstellar travel. Of course, no one said that out loud, not yet. In science, imagination walks carefully. It is permitted to whisper, but never to declare. Still, the thought lingered, moving through research groups like static on a radio signal. A researcher at the Max Planck Institute proposed an experiment to model how light would scatter off carbon structures arranged in microscopic lattices, similar to what engineers call graphene. The simulations were uncanny. When stacked in certain configurations, those sheets produced the same extreme negative polarization seen in 3I Atlas. The resemblance was too close to ignore. "It's as though the particles have geometry," she wrote in her report. "Not random, but intentional geometry." Meanwhile, the James Webb Telescope provided another clue. It captured the mid-infrared emissions of the dust cloud and found that the thermal properties were inconsistent with porous, fluffy cometary grains. Instead, they behaved like dense, smooth surfaces capable of holding heat longer than ice ever could. That was the moment the term reflective refractory compound appeared in the literature, another way of saying metal-like. By then, the excitement had mixed with unease. If the dust of 3I Atlas was indeed metallic or carbon lattice-based, then the object must have endured temperatures so high that ordinary comets would have evaporated. It meant this traveler had survived conditions near a star or inside a region of violent radiation, and yet here it was, intact, serene, gliding past our sun as if unaffected by its warmth. You might think, well, perhaps this is merely exotic chemistry, the product of an alien system's extremes, and perhaps it was, but the data kept challenging that comfortable notion. The polarization varied with time in rhythmic pulses, almost synchronized with the periodic outgassing recorded weeks earlier. It was as though the same process that released gas also rearranged the dust, reorienting the tiny metallic particles in response to sunlight. Such coherence is not random. It requires feedback, something akin to sensitivity, almost awareness. An astronomer in Japan, watching the pattern unfold night after night, compared it to the shimmer of a living skin responding to light. His words, translated later, caused a small stir. "It behaves as if it wants to be seen." In Washington and Darmstadt, the data reached other audiences. The Department of Defense, through its partnership with the Planetary Defense Network, classified sections of the polarization maps as sensitive, citing national security. To the scientists involved, that seemed absurd. What danger could there be in light scattering? Yet, quietly, some understood. Because if that dust was metallic, if it bore traces of artificial structure, then humanity might be staring, for the first time, at debris, not of nature, but of craft. Still, evidence must always precede belief. Teams in Hawaii and Chile continued their observations. They rotated filters, adjusted wavelengths, searching for more clues. What they found deepened the mystery. The negative polarization grew stronger at smaller phase angles, reaching a level nearly unprecedented -2.5%. That number might sound meaningless, but it is the kind of number that keeps scientists awake at night. It implies surfaces smoother than glass, materials engineered to scatter light in ways no random dust could. In one late-night discussion, a physicist tried to explain it to a journalist. "Imagine you're looking at a field of snow," he said. "When sunlight hits, it scatters, it dazzles, but it's random. Now imagine every flake in that field is aligned, each one polished like a mirror, all facing in near-perfect coordination. The light would no longer just reflect, it would speak. And that is what 3I Atlas seemed to be doing, speaking in light. The question then became, what was it saying? Some thought it might be a coincidence, a quirk of geometry and chance. Others began to whisper of technosignatures, the subtle footprints of technology written in the language of physics. SETI researchers, usually focused on radio waves, took note. Here was a silent object that seemed to encode complexity, not in transmission, but in reflection. One cannot help but feel humbled by such thoughts. For centuries, we have gazed at the heavens, sending our signals outward, hoping for an answer. And now, perhaps, the answer had arrived wordless, drifting, disguised as dust. But science does not move on whispers alone. To test the hypothesis, a coordinated observation campaign was launched. Instruments measured the polarization at multiple wavelengths, from optical to near-infrared. The results were consistent. The dust grains were not irregular. They were plate-like, possibly hexagonal, as though crystallized in two-dimensional layers. In a laboratory, such structures can be grown atom by atom. In space, they require processes we do not yet understand, or perhaps processes that were once understood by someone else. There was a night, recorded in an internal memo from an observatory in La Palma, when one scientist wrote, "We are looking at the ashes of something exquisite." It was not a formal conclusion, merely a feeling one born of staring too long at the impossible. The pattern of polarization shifted again, as 3I Atlas continued its journey, weakening as it drifted farther from the Sunday. The symmetry broke, the metallic sheen faded, and the dust became ordinary once more. Some took comfort in that return to normalcy. Others saw it differently, as if the object, having revealed a glimpse of its nature, chose to dim itself again, to retreat into silence. In the quiet aftermath, debates erupted. Was this merely an exotic comet, a relic from the cold forges of another star? Or was it something more, a fragment, perhaps, of a vessel or probe long dead, its remains disguised by time and ice? No consensus formed, but beneath the arguments ran a current of reverence, because whatever 3I Atlas was, it carried within it a reminder that matter itself can hold memory. Each photon of light, each polarized wave, was a clue to something older than our species, something that had traveled across eternity to find its reflection in our eyes. And that reflection, shimmering in the data, seemed to whisper a deeper question. If the dust of the universe can remember, then what else might it preserve? That question would not fade, because in the days that followed, the James Webb Telescope recorded something even stranger, a thin spectral line in the object's emission, corresponding to a form of nickel that should not exist in isolation. It was faint, but precise, as if carved into the spectrum itself. The scientists called it the nickel line, and it would open a door that few were ready to walk through. It began as a faint whisper in the data, a thin thread of light threading through the spectrum like the glint of a blade beneath dark water. The spectrometers aboard the James Webb Space Telescope caught it first, a narrow emission line at a wavelength corresponding to neutral nickel. It was subtle, almost lost amid the broader molecular bands of carbon dioxide and dust. Yet the precision of it drew immediate attention, because it should not have been there. In comets, nickel emissions are rare, and when they do appear, they are always accompanied by the spectral fingerprints of iron. The two metals are born together in stellar furnaces, locked in ratio, inseparable in origin. But 3I Atlas defied that rule. Its light carried nickel, pure and unaccompanied, shining alone in the dark. The discovery came in the early hours of a Sunday, when most of the team had long gone home. A graduate student noticed the anomaly while cross-referencing exposure frames and sent an uncertain message to her supervisor. Within hours, the observatory's internal channels were alive. By dawn, the nickel line had been confirmed independently by telescopes in Chile, Hawaii, and even the Ukrainian infrared facility at Terskol. The pattern held. A single atomic signature, persistent, unwavering, and unexplainable. The question was immediate. What could produce nickel emission without iron? The simplest answer was none of the natural processes we knew. Inside comets, the heating of metallic grains releases both elements together, their spectra braided like twin strands of the same story. But here, the iron was missing entirely, as though scrubbed clean. The models failed to reproduce it, no matter how the parameters were tuned. To many, it felt less like an observation, and more like a message, one written in chemistry rather than words. In the following days, teams around the world reanalyzed their data, searching for instrumental error. None was found. The emission's intensity oscillated slightly with the object's rotation, strengthening and fading in rhythm, as if linked to the outgassing vents that had puzzled scientists weeks before. It was not a noise artifact, nor a cosmic ray, nor a calibration flaw. It was real, the light of nickel, whispering from the halo of an interstellar traveler. You see, nickel is not a trivial element. It is the signature of creation and decay. Inside stars, it forms in the final stages of fusion, when the forge begins to cool. In human hands, it is the skeleton of machinery engines, reactors, alloys. To find it isolated in the breath of a comet was like finding the smell of iron in a snowstorm. It did not belong there. The research community divided quickly. Some argued it must be an exotic form of chemistry, born in an environment where carbon monoxide and nickel reacted under pressures unknown to our system. Others dared to venture further. There exists, they said, a compound called nickel tetracarbonyl, a gas so volatile, so reactive, that it forms only under precise industrial conditions. On Earth, it is created when carbon monoxide binds with nickel metal in a vacuum chamber, producing a substance used to purify alloys. In nature, such a reaction is almost impossible. It requires temperatures, pressures, and concentrations that no comet can sustain. And yet, when spectroscopic models were run against the data, the fit was uncanny. The ratio of absorption peaks, the emission's narrow width, even the way the line shifted slightly with solar illumination, all pointed to the same improbable conclusion. The nickel detected around 3I Atlas might exist in molecular form, bound to carbon and oxygen as if engineered. The thought lingered like static in the control rooms. If true, it meant we were witnessing not geology, but alchemy matter shaped by intent. In one of the early briefings, a senior chemist presented the findings with professional caution. "There are," she said softly, "two possible interpretations. Either we are seeing a rare natural chemistry occurring under conditions we do not yet understand, or we are looking at the residue of a process that once had purpose." Around the room, silence held. No one wanted to say the word, but they were all thinking it. Technology, the press, never heard that phrasing. Officially, the data was under review. But behind the veil of non-disclosure agreements and encrypted correspondence, scientists debated what it meant for a material once refined or built to survive across the void. Some speculated it could be remnants of an ancient probe, its hull reduced to dust over eons. Others wondered if it might be the debris of something grander, a self-sustaining object, once powered by the decay of metals, now cold and drifting. And yet, the more they studied, the stranger the pattern became. The nickel emission wasn't diffuse, as it would be if gas simply evaporated from a surface. It came in sharp, pulsed bursts, localized in spectral space. When mapped over time, the intensity curve formed a rhythm, regular, almost coded. Some compared it to Morse, though that was a poetic exaggeration. Still, the cadence was undeniable, like a slow heartbeat buried beneath the hum of the cosmos. The Webb telescope team called this pattern the nickel code. It was not an official term, but the name caught on. For a brief moment, it seemed the entire astronomical world had become a cryptographer, staring into the noise, searching for order. Could the ratio between peaks, the timing between pulses, the modulation with sunlight, all of it be conveying something? Or was it simply nature's accident, a beautiful symmetry mistaken for meaning? Perhaps that is the oldest question in all of science: how to tell the difference between chaos that looks like order and order that hides within chaos. In Geneva, a young physicist tried to model the emission as a feedback between sunlight and magnetic particles. The simulation failed spectacularly, producing patterns far too irregular. "It doesn't breathe like that," she wrote in her report. "Whatever this is, it's consistent. It remembers." Meanwhile, the political machinery began to move. NASA issued a statement acknowledging unusual, metallic signatures, but assured the public that all phenomena remain within the bounds of natural astrophysical processes. Yet inside the private channels of the Planetary Defense Coordination Office, a very different tone prevailed. Documents later leaked described the observation as potential technosignature candidate pending verification. The phrase was cautious, bureaucratic, but it was historic. It marked the first time an official body had used that term in reference to a physical object, rather than a radio signal. Across the Atlantic, the European Space Agency quietly convened a task group on non-standard material composition in interstellar objects. But participants later described an atmosphere of equal parts awe and dread. One attendee recalled looking around the table and realizing that no one wanted to be the first to say what they all suspected. Because if 3I Atlas was natural, it expanded the boundaries of chemistry. But if it was not, if it bore the fingerprint of intent, then it expanded the boundaries of everything else. And so, the debate deepened. The skeptics proposed exotic natural explanations: nickel grains condensed near a carbon monoxide-rich protostar, photochemical reactions in deep space, even unknown isotope effects. Each theory was possible, but each strained at the edges of plausibility. The believers, though cautious, began to frame another vision. What if 3I Atlas was a relic? Not a vessel in the science fiction sense, but a fragment of ancient industry, a shard of technology, cast adrift, now masquerading as stone and ice. When you think about it, the idea is not absurd. Humanity itself has already launched artifacts that could, in some distant age, drift into other suns. Voyager, Pioneer, New Horizons all bear traces of our presence. If someday a civilization were to find them, what would they see? Perhaps a metallic echo among the dust, glowing faintly with chemical, lines that seem too deliberate, too pure. It's humbling to realize that our debris, too, might one day become a mystery. The term nickel code began appearing in more formal contexts soon after. Researchers plotted the emission frequencies as time series data, converting light into sound to listen for structure. The result was eerie, an oscillating tone, rising and falling with mathematical precision. Some heard a pattern, others heard coincidence. But all agreed that 3I Atlas had become more than a comet. It had become a question written in light and metal. In late December, a paper circulated privately among several observatories. It proposed that the nickel emission was the byproduct of a catalyzed reaction nickel, reacting with carbon monoxide to form the very compound once thought impossible in space. The authors concluded with an unsettling line: if verified, this mechanism may indicate an organized chemistry, self-sustaining and non-biological. That phrase, non-biological but organized, hung in the air like a chill. It described something between life and machine, a bridge between matter and meaning. Meanwhile, the public story remained muted. Press releases spoke of progress in understanding interstellar chemistry, while internal memos used the language of containment and coordination. One phrase appeared repeatedly: defer publication pending review by defense liaison. It was, perhaps, the most eloquent silence of all, and still the object glided on, indifferent to our debates. The nickel emissions continued to pulse faintly, as it arced past the sun and began its slow retreat toward the outer system. The brightness faded, but the questions only deepened. Somewhere in those waning weeks, an astronomer watching from a mountain in Chile sent a simple message to her colleague. If this is natural, then nature dreams. It was the kind of line that belongs more to poetry than physics, but perhaps the two are not so different. Both are attempts to translate the untranslatable. By early January, 3I Atlas was slipping beyond the reach of most telescopes. Its spectral voice grew dim, the nickel line dissolving into noise. But the traces remained in the data, in the memory of those who had glimpsed something that refused to fit the boundaries of known creation. And in its wake, a new tension began to grow. Because if the object was indeed the residue of technology, then someone, somewhere, would want to control that knowledge. And that, of course, would lead to the next chapter of the story, the quiet mobilization that began as the object drifted outward, when science found itself watched by eyes, not of curiosity, but of strategy. It started quietly, as these things often do, small adjustments in orbital data, brief flashes on classified tracking logs, a few lines of code rewritten in satellite command systems. And yet, those subtle shifts would come to mark the beginning of what later analysts called the silent mobilization. The world's defense infrastructure had begun to move, not with noise or panic, but with precision, like a great machine waking without sound. At first, it seemed procedural. The United States Space Command requested new observation windows on their infrared satellites, citing calibration updates. The European Space Agency redirected the antenna arrays of their deep space network toward a sector they refused to name. In Japan, the Yasuda Radar Telescope received orders to resume 24-hour monitoring of a transient celestial body. None of these events, alone, meant anything unusual. But when viewed together, when their timelines aligned with the trajectory of 3I Atlas, the pattern became impossible to ignore. The object, officially classified as non-threatening, was being treated as though it were a weapon. In the early days of December, the shift grew visible to those who knew where to look. Military-grade telescopes, typically used for monitoring orbital debris and missile trajectories, were suddenly booked solid under shared research coordination. The phrase was a polite fiction. It meant the lines between civilian science and defense had blurred once more, just as they had during the height of the Cold War. And yet, there was no announcement, no warning to the public. Official channels maintained that 3I Atlas posed no danger to Earth. NASA's outreach statements were calm, almost poetic, emphasizing curiosity, discovery, unity. But behind the curtain, the tone was different. A secure communiqué circulated among the partners of the International Asteroid Warning Network. It read, in part, Pending Object Classification Review, Planetary Defense Protocols, Phase 2, to be enacted under Precautionary Directive, Phase 2. Those two words carried a gravity understood by few outside the system. In theory, Phase 2 referred to enhanced observation and readiness tracking, modeling, and coordination between space agencies. In practice, it meant that defense systems were being quietly placed on standby. To put it simply, the world had raised its shields. Why, though? That was the question that haunted the scientists who had devoted their lives to reason. 3. Atlas was no threat. Its path would not cross Earth's orbit by tens of millions of kilometers. It was a wanderer, not a weapon. And yet the behavior of governments suggested otherwise. Perhaps it was fear not of impact, but of implication. The nickel line, the metallic dust, the strange perfection of its orbit, all of it hinted at something not easily categorized, something that resisted the safe language of science. And in the absence of certainty, bureaucracy does what it always does. It prepares for the worst. In those days, the skies above Earth were busier than they had been in decades. Radar arrays swept arcs across the heavens, tracking the faint echo of a body smaller than a mountain but larger than most satellites. Defense networks that had once been rivals American, Russian, European, Chinese seemed to coordinate in eerie silence. Even nations without deep space programs offered their sensors, their data, their silence. It was as if the planet, for a brief and uncanny moment, had agreed on one thing. Something was coming, and it was better to act than to ask. At Vandenberg Space Force Base, 2 reconnaissance satellites were retasked under an operation labeled Spectral Cascade. The mission, according to later declassified documents, involved testing the ability to detect minute thermal signatures from objects in deep space. The timing was too perfect to be coincidence. Meanwhile, the European infrared satellite, scheduled for routine maintenance, remained active and pointed continuously toward 3I Atlas. In Washington, budgetary emergency clauses were invoked to reallocate funds for planetary observation. All of this for a comet officially described as harmless. The contradiction was so sharp, it became almost philosophical. When we are told not to fear, and yet we see the machinery of fear moving all around us, which truth do we believe? The words or the actions? Those who remembered history recalled an earlier precedent, the small asteroid TC3, detected in 2008. It was the first object ever predicted to hit Earth, a harmless meteor that exploded over the Nubian desert. But the hours before its impact were chaos. Fighter jets scrambled, satellites shifted, radar networks lit up like constellations of anxiety. Humanity, for the first time, had glimpsed its own reflex, the instinct to respond not with calm, but with readiness for war. Now, with 3I Atlas, that reflex had returned. Though no impact was expected, the difference was subtle but crucial. This time, the mobilization was preemptive. There was no explosion to fear, no countdown, only curiosity wrapped in secrecy, and the invisible hum of systems coming online. Reports surfaced from amateur astronomers noting strange interference in their telescope feeds. Some blamed solar weather, others suspected intentional signal jamming. In truth, communication channels were being saturated by defense relays, encrypted transmissions bouncing between geostationary satellites. The sky had become crowded with watchers watching the watcher. One night, in a dim operations room in Colorado Springs, an officer overseeing the space-based infrared system stared at his monitor as a faint blip crossed the field. The infrared signature was steady, too steady for natural reflection. He called in the readings. Within minutes, a chain of alerts triggered across agencies. Later analysis dismissed it as sensor noise, but those present swore the object had emitted a pulse, a momentary flare of energy, unlike sunlight. It was never officially recorded. By mid-December, the tension had become palpable. Behind closed doors, scientists were being asked to draft worst-case scenarios not of impact, but of interaction. If the object alters trajectory, one document read, "Initiate contingency protocol." That phrase, contingency protocol, usually referred to Earth defense simulations practice for asteroid deflection, for planetary protection drills. But this time, no one called it a drill. The Air Force relocated a classified early warning aircraft to the Pacific, under the justification of orbital monitoring. The European radar installations in Norway were instructed to track low-frequency reflections. Even the Chinese Academy of Sciences, usually cautious in international cooperation, published a statement about global coordination for potential celestial anomalies. It was the closest they could come to admitting concern. And all the while, 3I Atlas continued its slow, untroubled arc across the inner solar system, shining faintly against the velvet dark. It offered no threat, no aggression. The danger, if there was one, was entirely human, danger of reaction itself. Perhaps that's the irony of it all. We spend centuries dreaming of visitors from the stars, and when one arrives, our first instinct is to prepare our weapons. Not to attack, but to protect something far more fragile, our sense of control. The more the defense system synchronized, the quieter the scientific community became. University researchers found their observation windows abruptly cancelled. Data servers that once streamed public comet readings began returning access errors. Requests for information were routed through defense departments rather than research institutions. The line between discovery and surveillance had blurred into invisibility. At the European Space Operations Centre, a young astronomer reportedly asked her supervisor, "Are we studying it or guarding against it?" He hesitated before replying, "Both, I think, until we know which one matters more." That hesitation, that inability to decide whether the unknown should be met with wonder or with caution, defined the moment. It was not war, not yet, but something close. The posture of readiness without clarity, vigilance without target. Somewhere in the silence, satellites adjusted their orientations to face the visitor directly. Infrared sensors waited for heat. Radio antennas listened for whispering static. Ground-based lasers calibrated in case of interception simulation. None of these systems ever fired, but the fact that they were ready spoke volumes. And then, abruptly, communications from several observatories ceased, not all at once, but in a wave one after another, a global data blackout. Official explanations ranged from maintenance to solar interference, but those within the networks knew better. Access to 3 Atlas observations had been locked under a single classified clearance. The reason given: national security. The world above had entered shadow mode. In retrospect, some historians would later call it a rehearsal, a planetary defense drill cloaked in secrecy. But at the time, no one dared to use that word, because a drill implies control, and there was none. Only the faint, growing sense that the visitor had become a mirror, reflecting our fears. And perhaps that was the real story, not that humanity prepared for war, but that it could not tell the difference between defense and discovery, between the instinct to protect and the longing to understand. As the year drew to a close, the object began its retreat toward the dark. The mobilization slowed, but the silence remained. And in that silence, a new tension began to grow, one not born of the military, but of the scientific community itself. For when governments begin to hold the sky under lock and key, the question arises quietly among those who once studied it freely. What happens when curiosity becomes classified? And that question, like a flicker of distant light, would guide what came next. When the silence fell, it did not arrive like a storm, but like a fog. Soft, unannounced, seeping through the cracks of the world's observatories and laboratories. One day, the data streams were open numbers, light curves, radio echoes flowing freely from telescope to telescope across continents. And then, without warning, the flow stopped. Researchers who had been tracking 3I Atlas woke to find their access credentials revoked, their observation schedules postponed pending review. Automated uploads from ground telescopes now returned error codes, and the shared repositories that once bound the scientific community together displayed only a sterile message: access restricted. At first, many assumed it was technical. Networks fail, servers crash, protocols update. But when emails to NASA, ESA, and JAXA went unanswered, and when even private observatories in Chile and South Africa were told to suspend their data collection, a different realization began to settle in. This was not a malfunction, it was an embargo. The justification came days later, in a carefully worded notice circulated to partner institutions. In light of ongoing verification efforts, and to ensure scientific accuracy, dissemination of preliminary data related to Object 3, Atlas, will be temporarily restricted. It was a bureaucratic sentence, calm, neutral, precise, and yet, beneath its composure, it carried the faint scent of fear. Because science, you see, thrives on transparency. Data is oxygen. When that flow is cut off, something deeper begins to die. At the European Southern Observatory, an astrophysicist named Morales described the feeling in his notes. It's as if someone dimmed the lights in the room. We can still see the stars, but only through the curtains they choose to draw. Across the Atlantic, the same pattern unfolded. Research groups who had been independently analyzing spectra from 3I Atlas suddenly found themselves locked out of high-resolution archives. Proposals for follow-up observations were rejected without explanation. Even time on privately funded telescopes, those outside national agencies, was quietly rescinded. The message, though unspoken, was clear. Stand down. The phrase that circulated among scientists was data freeze. It sounded harmless, almost administrative, but in the long corridors of academia, it carried weight. The freeze meant that information about 3I Atlas had entered a liminal space, neither science nor secrecy, suspended between curiosity and control. To the public, nothing seemed amiss. News outlets continued to publish cheerful updates about the enigmatic interstellar comet, quoting sanitized statements from space agencies. The official tone was one of optimism, of progress. Further analyses are ongoing, NASA said. We are working closely with our international partners to understand this fascinating visitor. But within the community, silence grew heavy. Rumors began to circulate, whispered over encrypted chats and late-night calls. Some said the embargo was driven by the discovery of materials inconsistent with known physics. Others claimed it was a precaution against information misinterpretation. And a few those who had glimpsed the nickel line before it vanished from public datasets suspected the truth lay somewhere far stranger. One of them, a spectroscopist in Geneva, wrote anonymously in a forum that was later deleted. We are told this is about scientific caution. But the level of coordination, the way communication has been centralized, this is not caution. It is containment. Containment. The word resonated, not because it confirmed conspiracy, but because it revealed a deeper tension, the age-old conflict between knowledge and power. For centuries, science had prided itself on openness. But here, before an interstellar enigma, that openness was quietly rewritten under the vocabulary of security. You see, every great discovery forces us to confront not only what we know, but who gets to know it. And so, the lines began to blur. Scientists were asked to sign non-disclosure agreements. Funding bodies reminded researchers that failure to comply with coordination protocols may jeopardize institutional partnerships. Some teams were reassigned to other projects, their observation logs sealed under the guise of national review. A few resigned in protest. Most stayed, unwilling to lose access, hoping the silence would lift. But it did not lift. Weeks passed, and the embargo hardened into routine. Those who asked too many questions found their research proposals mysteriously denied. The language of cooperation, the same that had built the International Asteroid Warning Network, was now used to justify secrecy. Words like oversight, verification, and interagency coherence became code for something unspoken: control. And the irony? Well, it was exquisite. For years, humanity had dreamed of discovering signs of intelligence beyond Earth. But now, faced with even the faintest hint of that possibility, a pattern in metal, a whisper in light, our first instinct was not to share, but to hide. In the cafes near observatories, conversations turned philosophical. What if knowledge itself had become a kind of weapon? Not because it could harm, but because it could disrupt the delicate balance between nations, between governments, between belief and disbelief. An old astronomer in Santiago was quoted saying, "Truth is no longer measured by what is known, but by who is authorized to speak it." He was not wrong. The idea of a data embargo was not new. It had existed in other missions, the DART test, for example, or the Sentinel program projects where science and defense overlapped. But this was different. This was not an asteroid headed for Earth, not a weapon or a threat. This was a comet, drifting harmlessly through space. And yet, it had been placed behind the same veil as military technology. Why? Perhaps because it challenged the most fragile boundary of all, the one between what we can explain and what we cannot. In early January, a leaked memo surfaced online, briefly, before vanishing again. It was addressed to a classified working group known as the Astromaterial Oversight Council. The memo referenced anomalous spectral features and sensitive cross-domain implications. The language was cryptic, bureaucratic, but one line stood out. The need for narrative consistency outweighs the benefit of premature disclosure. Narrative consistency. It was a phrase born not of science, but of politics. For the first time, many in the research community began to grasp the magnitude of what was happening. This was not merely about data, it was about control of meaning. Whoever controlled the story of 3i Atlas would control how humanity perceived it. And perhaps that, more than the object itself, was what frightened those in power. Still, fragments leaked through. A few independent astronomers, using older instruments outside the formal network, continued to track the visitor. Their findings, though limited, confirmed that its brightness had fluctuated again, just as before, steady pulses, rhythmic, deliberate. But without access to high-resolution data, their voices were easy to dismiss. Unverified, said the agencies. Inconclusive. The word inconclusive became a shield. It protected institutions from doubt, and it protected the public from wonder. Somewhere in that growing silence, a new kind of question began to take shape, not about the comet, but about us. What does it mean when knowledge becomes classified? When curiosity must ask permission? When the universe speaks, and we respond by turning off the microphones? It was as if humanity had stumbled upon a mirror, and instead of gazing into it, we covered it with cloth. In time, the scientists adapted to the quiet. Some redirected their work toward other stars, other phenomena. Others, restless and disillusioned, began to share data privately, building a shadow network of truth seekers. They passed encrypted files, fragments of spectra, snippets of observation logs. They became, in their own way, the underground of curiosity, rebels not against authority, but against forgetting. One of them, writing under a pseudonym, described it beautifully. We are custodians of a silence we did not choose, but silence, like gravity, cannot hold forever. In February, faint rumors began to circulate that the object's data had been reclassified once more, not as a scientific anomaly, but as a planetary defense asset. No one knew what that meant. Perhaps it was legal jargon, or perhaps, quietly, the world was preparing to use the visitor for something else, to test, to measure, to simulate. The distinction between studying the unknown and weaponizing it had never felt thinner. And as that realization spread, the final questions of ethics emerged. If discovery can be hidden, if data can be owned, then what remains of science itself? Can truth survive if it must pass through the filters of secrecy? Perhaps the answer lies not in policy, but in something more human, in the courage of those who look up, still, despite the silence, and continue to ask why. Because in the coming weeks, those whispers of secrecy would give way to something even stranger, the sudden surge of activity that no one could explain. Telescopes once shut down would be turned back on. Satellites reoriented, military frequencies repurposed. Something was happening, something that felt less like suppression and more like rehearsal. And soon, the world would learn that what had been hidden under the name of caution might, in truth, have been preparation. The first hints came quietly. Buried in bureaucratic language, phrases like simulation readiness, interagency validation, response chain verification, words that could mean anything, and therefore everything. But to those who had watched the ebb and flow of classified directives since the arrival of 3I Atlas, they marked a shift in tone. The world, it seemed, was preparing for a test. Not of science, but of itself. At the beginning of March, a joint statement appeared on NASA's internal communication board. Planetary Defense Readiness, Exercise Coordinated, Phase Deployment. It was brief, devoid of detail, and signed by representatives from multiple agencies, including the European Space Agency and the US Space Command. Most readers dismissed it as routine, a desk exercise, another tabletop rehearsal for asteroid impact preparedness. Yet the timing could not be ignored. The object 3I Atlas was now receding toward the outer solar system, still glowing faintly, still under strict observation. To the outside world, the visitor had faded from headlines. But behind the curtain, its shadow had deepened. The systems that had been mobilized in silence during its approach were now reawakening, this time not under the pretense of secrecy, but under the language of practice. It was as if the world's institutions had decided that the only way to explain their earlier actions was to pretend they had been a drill all along. You see, that's the beauty of plausible deniability. It can turn panic into policy and policy into purpose. On paper, the planetary defense drill was elegant. It proposed a full-scale rehearsal of the procedures to be followed in case of a genuine interstellar threat. Early detection, international coordination, orbital prediction, impact assessment, and communication management. But when you looked closer, you saw the subtext. The timelines matched precisely with the observation data of 3I Atlas. The object used in the simulation was described as a non-terrestrial body exhibiting anomalous properties. The instructions were to maintain real-time tracking as though the event were authentic. It was a simulation using reality as its stage. At NASA's Goddard Center, some scientists were uneasy. "This isn't a drill," one of them told a colleague. "It's a mirror." For weeks, they had been told to treat the 3I Atlas data as hypothetical, to process it as though they were rehearsing for an event that had already happened. It was a strange inversion of logic science, pretending to simulate an observation that was itself the source of simulation. And perhaps that was the most unsettling part, the blurring between testing and truth. Across the Atlantic, the European Space Operations Centre coordinated the exercise with near-military precision. Ground-based radars, deep space tracking dishes, even low-orbit satellites participated. The global network that had once been built for discovery had now been repurposed into a shield, a planetary nervous system, rehearsing its reflexes. It was breathtaking, in a way, to see humanity act as one organism. But it was also haunting, because drills have rules, and one of them is control. The public, of course, knew nothing. There were no announcements, no media briefings. The word exercise never left the corridors of power. What the public did see, however, were the faint traces, unusual flight paths of military aircraft, an uptick in encrypted satellite transmissions, and a sudden spike in observatory closures due to maintenance. To the few who paid attention, it all seemed too synchronized to be coincidence. One might wonder, what harm is there in a rehearsal? After all, preparedness is prudent. Yet the deeper issue was not the exercise itself, but the secrecy wrapped around it. In practicing for a possible catastrophe, humanity had begun to act as if one were already unfolding. At the United Nations Office for Outer Space Affairs, an internal report circulated outlining the scope of cooperation between spacefaring nations. The tone was triumphal, unprecedented coordination, data-sharing agreements, rapid communication protocols. But in its final paragraph, a curious line appeared: public transparency to be limited to post-evaluation phase upon consensus. Post-evaluation. meaning only after the drill and after whatever truths it might conceal was complete. And so, while the world went on unaware, the rehearsal began. Over 3 days in mid-March, observatories across 5 continents synchronized their instruments. Simulated alerts were sent through the International Asteroid Warning Network, mimicking the discovery of a fast-moving interstellar object with potential Earth interaction. The data used was, of course, real. It came from 3I Atlas. The parameters were real too: its speed, its orbit, its chemical anomalies. The only fiction was the declared risk. It was, perhaps, the most elaborate dress rehearsal in the history of the planet. Inside the command centers, large screens displayed trajectory models, impact predictions, and theoretical deflection strategies. Engineers tested communication delays between agencies. Defense organizations practiced transferring observation data through encrypted channels. Artificial impact zones were projected over the Pacific, then erased. Every stage of the process unfolded with mechanical precision. And yet, throughout it all, an unspoken thought hung in the air. What if the simulation were not a simulation at all? Some participants later admitted they could no longer tell the difference. The object they were tracking, the emissions they were analyzing, they were real. Only the language around them was hypothetical. It was a kind of psychological sleight of hand. By calling it a drill, they could act without panic. But by acting without panic, they were, in truth, responding to fear. At the Space Situational Awareness Center in Darmstadt, a systems analyst noted something unusual during the second night of the exercise. The infrared sensors registered a faint but measurable fluctuation in the direction of 3I Atlas, an increase in reflected light, inconsistent with its distance. It lasted less than an hour, dismissed as sensor noise. But it left a question that no one dared pursue. Had the object reacted to the scrutiny? Of course, officially, the data was expunged from the exercise logs. But word spread quietly among the participating scientists. The visitor winked, they said in jest. It became a kind of private superstition, a joke that was not a joke at all. And perhaps that is the paradox of such rehearsals. They blur the border between caution and revelation. Still, from a bureaucratic perspective, the drill was a success. Reports concluded that international coordination had improved, response times shortened, and communication channels strengthened. Recommendations were made for future rehearsals. The language was clinical, efficient, but between the lines there was a different story, a faint pulse of something unacknowledged, the realization that the world had just conducted its first global planetary defense test, using a genuine interstellar visitor as its focus. A few participants privately expressed discomfort. "We rehearsed reality," one of them said. "We used the unknown as a prop, and now I'm not sure which part was fiction." And yet, others saw something noble in it. Perhaps humanity needed this kind of practice. Perhaps the universe was offering us a lesson disguised as coincidence, a cosmic fire drill, reminding us that vigilance could be an act of hope. Still, the ethical questions remained. Was it right to involve an unsuspecting public in such a rehearsal, without consent, to stage a planetary defense exercise under the guise of scientific observation? To merge the lines between transparency and control, all in the name of readiness? Philosophers and ethicists who later reviewed the incident would describe it as a shadow contract, an implicit agreement between governments and their citizens, written not in law but in a mission. The people were not lied to, one wrote. They were simply never told the truth. But the implications extended further, because once the mechanisms of secrecy are built, they rarely go unused. The infrastructure for planetary defense was now a living system, tested, calibrated, and quietly operational. And while the rehearsal had ended, the machine remained awake. For the scientists who had participated, something had changed. The silence that had once felt imposed now seemed self-inflicted. They had learned to censor their own questions, to accept half-truths as stability. A new kind of fatigue settled in, not from ignorance, but from the weight of knowing too much and being unable to speak. And so, the world moved on. The exercise was never officially acknowledged. The reports were sealed, the data archived under layers of classification. 3i Atlas faded once more into the void, carrying its secrets with it. But the system inspired the planetary shield. The readiness machine remained humming quietly in orbit. Then, in early April, something curious happened. A group of independent astronomers, using small optical telescopes outside the official networks, detected faint residual emissions from the direction where 3i Atlas had last been observed. They published their findings in a minor scientific bulletin. The signature matched the nickel line, the same spectral fingerprint that had once been classified. And that small rediscovery, almost ignored by the mainstream, would reopen the question that the rehearsal had tried to bury. Was 3i Atlas ever just a comet? Or had it been something far more deliberate, something that forced us to prepare not for collision but for recognition? In the weeks that followed, comparisons to past interstellar visitors began to reappear. Oumuamua, Borisov, and now this. The pattern was unmistakable, though no one dared say it aloud. The universe was sending travelers more frequently, and each one left behind not chaos, but choreography. Perhaps, as one scientist quietly wondered, we were not rehearsing defense at all. Perhaps, unknowingly, we were being trained to meet. It was inevitable, I suppose, that comparisons would surface. The name 3i Atlas had barely faded from the public ear when older memories began to stir. Oumuamua, Borisov, those earlier messengers that had once crossed our skies like whispers from the deep. Together, they formed a pattern too elegant to ignore, a rhythm in time that felt deliberate. 3 visitors in less than a decade, after billions of years of silence. It was almost poetic. And perhaps, unnervingly, it was rehearsal. Oumuamua came first, the shard of light from another sun. It entered our solar system in 2017, like a blade through water, fast, tumbling, silent. When astronomers traced its orbit, they realized it was interstellar, the first of its kind. No comet tail, no plume of gas, only a faint shimmer of sunlight off a surface, both smooth and irregular. It was thin, elongated too long, some said, for a natural object, as if it were designed to sail on light itself. Its speed and trajectory defied perfect explanation. The official story, after months of analysis, settled on a fragment of rock, perhaps with a peculiar shape, but others saw in it something different, a probe, maybe, or a relic. And though most scientists dismissed that notion, the question lingered like dust in the light. What if nature was not the only artist at work? Then came Borisov in 2019, the second visitor, the one that made Oumuamua seem almost tame. Unlike its predecessor, Borisov looked familiar, a true comet with a tail of ice and dust, a chemistry that made sense. It was nature's reassurance, or perhaps its distraction. The interstellar unknown made knowable again. It soothed the public, calmed the narrative. See, they said, they're just comets after all. But to those who studied the data, Borisov carried its own quiet oddities. Its composition was too rich in carbon monoxide, its nucleus strangely robust, as though hardened for a journey longer than any comet should survive. And its origin, traced backward through the void, pointed toward a young star system still forming worlds. That meant it had come from a nursery of creation, not destruction, a messenger of beginnings perhaps, sent across the stars. And now, 3i Atlas, the third note in a cosmic chord. The one that blended the familiar with the impossible. Like Borisov, it had a coma and a tail, and so it wore the mask of a comet. But like Oumuamua, it refused to behave. Its light fluctuated too precisely, its chemistry too deliberate, its orbit too graceful. It was as though the universe had taken both of its previous visitors and combined them, crafting a lesson in pattern recognition. The first was mystery, the second reassurance, and the third, a test. You see, history rarely repeats itself exactly. It rhymes. And in those rhymes, meaning hides. Some scientists began to ask a dangerous question. What if these were not random? What if they were part of a sequence, a long conversation written in motion rather than sound? 3 arrivals in quick succession, each closer, each more complex. From the unadorned stone of Oumuamua, to the icy certainty of Borisov, to the metallic whisper of 3i Atlas, it felt like escalation, not of threat, but of sophistication. At first, the pattern was dismissed as coincidence. After all, interstellar objects must exist by the trillions, drifting unseen between stars. Perhaps we had simply built telescopes sensitive enough to see them at last, but the probabilities refused to align neatly. The frequency of such visitors, even accounting for improved detection, was too high. And their timing, each arriving within a few years of the last, strained the boundaries of statistical comfort. The odds were small, yet here they were. There's something deeply human about finding sequence in chaos. We read constellations into random stars, meaning into static. But sometimes, the universe plays along, as if indulging our imagination. And sometimes, imagination turns out to be recognition. By the spring of 2025, several research papers quietly circulated among closed academic circles, comparing the trajectories and physical characteristics of all 3 interstellar visitors. The correlations were subtle but striking. Each had entered the solar system at a high inclination relative to the galactic plane. Each travelled at a velocity consistent with the movement of local interstellar clouds, almost as if launched from within the same region of space. Most intriguing of all, the orientation of their approach vectors formed a rough alignment pointing toward the constellation Lyra, Vega's domain. That name carried a weight of its own. Vega, bright, ancient, the star Carl Sagan once imagined as the origin of our first contact. It was coincidence, perhaps, or maybe the universe has a sense of irony. Of course, officially, no agency endorsed such speculation. The reports were kept internal, categorized as pattern analysis, not hypothesis. But the whispers spread nonetheless. Some said the pattern was a cosmic cadence, others called it reconnaissance. And a few, the quiet radicals among them, believed it was education, that each object was designed to test how humanity reacts to the unknown. And that, you see, was the most unsettling idea of all. Because if that were true, then our fear, our secrecy, our readiness drills, and they were all being watched. Not by other nations, but perhaps by the very intelligence we had failed to recognize in the first place. In a private interview years later, an ESA official admitted something remarkable. During the planetary defense exercise in March, one of the simulation models, codenamed Echo, had run autonomously, without human instruction, and had adjusted parameters in real time to match observed data from 3i Atlas. It was as if the system knew what was coming next, he said, as though it were being guided by something outside our inputs. The log was never released. But that single comment fed a new thread of speculation, that we were not rehearsing alone. It's tempting to view these events as mere coincidence, the product of human pattern seeking, but when coincidence repeats often enough, it becomes history. Oumuamua, Borisov, Atlas, the trinity of interstellar visitors that redrew the boundaries of cosmic expectation. Each one taught us something new about ourselves. Oumuamua showed us how quickly we label what we do not understand. Borisov showed us how eagerly we cling to familiarity, and 3i Atlas showed us how fear disguises itself as preparedness. In each case, the visitor did not change the world, it revealed it. Perhaps that's the real function of these arrivals, not to threaten, not to teach but to reflect, to show us who we are when the unknown comes too close. Still, some within the scientific community refused to let the pattern go. They proposed long-term observation initiatives, permanent deep space sentinels positioned to detect future interstellar objects. Others, more pragmatic, sought to fold planetary defense into these new frameworks, arguing that every detection is an opportunity to rehearse again. The logic was persuasive. Practice makes survival. But beneath that practicality lay something quieter, a growing suspicion that the universe was giving us cues, and that we had better learn our lines before the next act. It's strange, isn't it? How quickly humanity learns choreography when fear provides the rhythm. Within a decade, we had built global coordination systems that once seemed impossible. Networks of telescopes, radar webs, rapid response protocols all operating seamlessly. The world had become, almost unconsciously, a single nervous system waiting for the next spark. And perhaps that is what the visitors were meant to trigger, not alarm, but adaptation. The pattern was clear enough that even skeptics began to concede a shift in probability. If 3 had come in less than 10 years, logic suggested there would be a fourth. Somewhere in the dark between the stars, another traveler was already on its way, indifferent to our expectations. And when it came, would we greet it with panic or with patience? Would we finally have learned how to listen rather than react? By now, the term planetary defense had taken on a new meaning. It was no longer just about shielding Earth from impact. It had become symbolic, the defense of certainty itself. Every telescope, every algorithm, every secret meeting was, in its own way, an attempt to preserve the illusion that we were still in control. But control is an illusion, a comfort against the vastness of the unknown, and when the unknown arrives again, as it surely will, that illusion will be tested once more. Somewhere, in the archives of the Planetary Defense Coordination Office, there exists a sealed document labeled Continuity Scenario. Few know its contents, but its existence has been verified. According to one brief mention in a leaked memo, it outlines standard response procedures for future anomalous interstellar arrivals. The language is cautious, procedural, but the title speaks volumes. Continuity, continuation, repetition, expectation. The assumption that this story is not finished, and maybe that's the truth we're circling without admitting. That 3i Atlas was not an isolated event, but a chapter in something larger, a narrative unfolding across epochs. Perhaps it has been happening for far longer than we realize, only now entering the age where our eyes are sharp enough to notice. If so, then the next arrival will not surprise us. It will feel like déjà vu, a familiar echo in the night sky. And maybe, by then, humanity will have decided whether to greet it as a threat, a teacher, or a mirror. For now, the sky is quiet again, though silence has never meant safety. The telescopes keep watch, the algorithms hum, and somewhere deep in the cold of interstellar space, another speck of light begins its long approach. But this time, the world will not be caught unprepared. This time, the rehearsal will not be practice, it will be performance. And perhaps that realization, whispered in the control rooms and observatories of Earth, is what leads us into the next chapter, the one where secrecy becomes doctrine, and truth itself begins to fracture under the weight of what we think we're ready to know. The pattern was now impossible to ignore. 3 interstellar visitors, each more complex than the last, each arriving just close enough to stir the same quiet unease. Oumuamua had been the whisper, Borisov the reassurance, 3i Atlas, the question that would not sleep. For a planet that had once believed itself alone, this rhythm of arrivals was beginning to sound like a message written across centuries of silence. Oumuamua had entered history like a riddle, tumbling end over end, flashing sunlight from facets too flat for any known rock. It showed no gas, no tail, only a strange acceleration, as it left the sun's gravity behind. Scientists bent the laws of motion to explain it, hydrogen ice, porous metal, radiation pressure, but each theory dissolved under the weight of its own improbability. Then Borisov came, carrying its own comfort, a comet at last, ordinary, predictable, dissolving beautifully in sunlight. Humanity sighed in relief, as though nature had corrected its own anomaly. And then, years later, came 3I Atlas draped in the familiar glow of dust and ice, yet layered with metals, symmetries, and rhythms that nature never writes by accident. It was both comet and artifact, the synthesis of the two archetypes that had divided us. To call it coincidence was possible, but the word felt small, like trying to name the wind with a whisper. Across universities and defense offices alike, a new phrase began to surface: the sequence. It was never official, but everyone understood. 3 arrivals do not make a pattern by mathematics alone. They make it by emotion, by narrative, by the human need to connect dots, and the sequence, as some quietly suggested, might not be finished. Theories multiplied like stars. Perhaps these visitors were fragments of a destroyed world, drifting in from a long-dead system. Perhaps they were remnants of some forgotten technology, flung outward in a storm of cosmic debris. And then came the idea few dared to say aloud. Perhaps they were probes, observers, explorers, seeds of intelligence cast into the void to bloom in other skies. SETI, the search for extraterrestrial intelligence, had always looked for signals, not stones. But now, scientists were forced to consider that communication might not come as a voice, but as a presence, a sequence of arrivals, each one a syllable in a language older than stars. Oumuamua, the question; Borisov, the reassurance; Atlas, the test. When the Planetary Defense Coordination Office debriefed its rehearsal, it used neutral language: response effectiveness, international readiness, data integrity. But one line in the classified appendix hinted at something deeper. Patterns observed across interstellar entries may suggest non-random distribution. Non-random. It was as close as any agency had come to acknowledging the possibility that we were not merely observing nature, but participating in dialogue. Still, official denial held firm. Science prefers humility to confession. Correlation is not causation, the reports repeated. But late at night, in dim-lit observatories, researchers stared at their plots and felt the hum of something more. They would never write it, never say it on record, but they felt it in their bones that perhaps the universe was speaking, and we were still learning how to listen. For the public, the story had become faint, almost forgotten. Oumuamua had been reduced to trivia, Borisov to textbook, Atlas to rumor. But in the hidden circles of those who studied them, the story was still unfolding. There was an unspoken agreement that if a fourth visitor appeared, if another interstellar traveler entered the solar system within a generation, it would no longer be possible to call it coincidence. It would be confirmation, though of what, no one could yet say. And so the eyes of the planet turned outward again, quietly, steadily, waiting. New telescopes were planned, new networks built, eyes not of wonder now, but of vigilance. The practice had become instinct. Humanity had been trained, perhaps without knowing, to respond to the unknown with procedure rather than panic. The drills had worked, the choreography was set. Maybe that was the point. Maybe each visitor was not just a phenomenon, but a lesson, a rehearsal for something larger than defense, an education in readiness, not for impact, but for contact. Because readiness, in its truest sense, is not about survival. It is about comprehension. In one of the few interviews given years later, a scientist from the European Space Agency described the feeling best. It's as though the cosmos is asking a question we haven't yet learned to translate. Each object is a different dialect of the same inquiry. What we call discovery might only be recognition. And recognition, when it comes, is rarely gentle. It breaks habits. It erases comfort. It demands that we reconsider who is watching whom. In the archives of the rehearsal, buried beneath layers of encryption, there is said to exist a document called Continuity Scenario, an outline for future protocols if the pattern continues. The final clause, according to rumor, reads simply, "In the event of repeat occurrence, transition from defense framework to engagement framework." Engagement. A single word heavy enough to tilt the future. For now, the sky has gone quiet again, though quiet is a relative term. The telescopes still hum, the data still flows, the silence still listens. Somewhere beyond Neptune, the faint tail of 3I Atlas drifts, fading into invisibility, carrying with it a question we have not yet answered. But deep within that silence, new rumors begin to stir unconfirmed sightings. Small anomalies, another faint glimmer entering the solar system from the dark between the stars. And if that light proves real, if another visitor truly comes, then this story will not end with astonishment, but with something more complicated: recognition without surprise, fear without denial. Because by then, we will have seen this before. By then, we will understand that the rehearsal was never rehearsal at all. And perhaps, as the next light approaches, the world will remember how it once reacted with secrecy, with control, with fear, and decide, this time, to do something different, because what follows recognition is not readiness, it is revelation. When the silence stretched too long, it began to fracture. At first, the fracture was small, a murmur here, a leak there, but like cracks in glass, it spread quickly, fed by pressure and heat, by the tension between what was known and what was withheld. Information, after all, behaves like light. You can block it, bend it, slow it down, but you can never contain it forever. And in the wake of 3I Atlas, humanity found itself trapped between the fading glow of the comet and the shadow of its own uncertainty. It started with the gaps. Data from official channels had grown sparse after the so-called planetary defense rehearsal. Observatories reported maintenance delays, datasets disappeared, and those few who had access to unfiltered telemetry were either silent or suddenly reassigned. The story, once alive with nightly updates, dwindled to the occasional bureaucratic statement, each one more diluted than the last. The public, of course, noticed. People always do, eventually. The hunger for knowledge is a primal thing, and when it's denied, the void fills with stories. Social networks lit up with speculation. Was NASA hiding something? Was the object artificial? Did it change course? The questions multiplied faster than any official could answer them, until they no longer sought answers at all, only narratives. You see, truth has a peculiar half-life. When left unspoken, it decays into myth. The first myths came from the usual corners: anonymous accounts, grainy telescope footage, self-proclaimed insiders, whispering of transmissions, of coded signals embedded in the comet's light. Most of it was nonsense, of course. But within the noise, a few fragments rang with unnerving familiarity, phrases that matched classified descriptions, references that only someone close to the data could have known. It was enough to ignite the fire. Within weeks, news outlets began to circle the story again. Articles appeared with cautious headlines, unanswered questions about the interstellar visitor. Why did NASA end the Atlas campaign early? The tone was polite, restrained, but the implication was clear. Something had been concealed. And in that atmosphere of suspicion, even the truth, had it been offered, might have sounded like another lie. Information asymmetry. That's the term used by sociologists, the imbalance between those who know and those who don't. But it's more than imbalance, it's erosion. It eats at trust like rust in metal. When people sense that knowledge is being filtered, they begin to construct their own versions of reality, each one shaped not by evidence, but by emotion. In 2025, that erosion became visible. Scientists who had once shared data openly began to face harassment online. public trust in official agencies plummeted. Every announcement was dissected for hidden meaning, every silence treated as proof. It was as though the mere act of withholding information had conjured a second universe, one built from conjecture and fear, orbiting parallel to the truth. And perhaps, in a strange way, it was inevitable. The universe abhors a vacuum. So does the human mind. Governments tried to regain control of the narrative. Press briefings were scheduled, transparency initiatives announced. Charts, models, and infographics flooded the internet, explaining the physics of comets and interstellar trajectories. But by then, it no longer mattered. The conversation had drifted beyond science. It was no longer about what 3i Atlas was, but what it meant, and meaning, unlike data, cannot be managed. Even within the scientific community, fault lines deepened. Some argued for openness, insisting that secrecy had done more harm than good. Others defended the restrictions, warning that unverified data could cause panic or misinterpretation. We must protect the integrity of science, they said. But in doing so, they protected its authority, and authority, once questioned, is never the same again. I suppose that's the paradox of knowledge. The more we try to contain it, the more it escapes through the smallest cracks, reshaping itself into something unrecognizable. In those months, the world learned how quickly mystery becomes currency. Conspiracy channels racked up millions of views. Podcasts promised to reveal the hidden history of interstellar contact. Amateur astronomers began selling footage of light anomalies, claiming they had rediscovered the nickel line. And though most of it was illusion, it filled the space left by official silence. People no longer needed proof, they needed participation. The unknown had become interactive. You could almost feel the pulse of it, this collective heartbeat of speculation. Humanity, it seemed, had found a new kind of entertainment, the performance of doubt. Meanwhile, in the corridors of power, the tone was less theatrical, more resigned. Internal reports circulated with titles like Public Communication Strategy, Post-Anomaly, and Mitigating Confidence Erosion. Behind the language of management was a deeper anxiety that the very institutions built to guide. Understanding had lost their gravitational pull. Perhaps they had forgotten something simple. Wonder is not a threat. Curiosity is not rebellion. People do not fear the unknown, they fear the silence around it. One memo, later leaked, captured the mood perfectly. It read, "The absence of timely information has created a vacuum now occupied by uncontrolled narratives. Restoration of public trust will require deliberate re-engagement." But re-engagement proved harder than anticipated. The scientists were exhausted, the agencies cautious, the politicians wary. Every new disclosure risked feeding the storm it sought to calm, and so, paradoxically, the silence deepened again. In that vacuum, another transformation began, not just in public opinion, but in perception itself. 3i Atlas became more than an object. It became a symbol. For some, it represented the arrogance of institutions that presumed to decide what the public should know. For others, it embodied the fragility of truth in an age of noise. And for a few, those still awake at their telescopes in the small hours of the night, it was a reminder of something more profound, that we had touched the edges of a story bigger than our comprehension and recoiled from it. Perhaps, if we had been braver, we would have kept the dialogue alive. But fear disguises itself well. It often calls itself responsibility. There's an image I can't quite forget. A photograph from one of the last public observation sessions before the data freeze. The comet glows faintly against the black, its tail diffused like breath on glass. Around it, in the dark, are the stars, billions of them, silent witnesses to our hesitation. And I remember thinking, the universe doesn't hide, we do. By late spring, the fever began to cool. The internet moved on, as it always does, leaving behind fragments of speculation like fossils of a brief obsession. Yet the damage endured. Trust, once fractured, does not heal, it calcifies, reshaping the landscape beneath it. Science retreated into caution, the public retreated into belief, and between them, a quiet loneliness settled, the loneliness of a species that no longer knows how to share wonder without fear. Still, some voices refused to fall silent. Independent researchers kept digging, tracing patterns in archived data, comparing notes from the earlier interstellar visitors. They found echoes, tiny consistencies in trajectory, in composition, in timing. Nothing definitive, but enough to rekindle the sense that perhaps 3i Atlas was part of a larger conversation, one that had not yet finished speaking. And that, in a way, brought the world full circle. Because the more we debated the unknown, the more we revealed ourselves. Our reflex to control, to protect, to possess knowledge, it was a mirror. The real story of 3i Atlas was not about what it was, but about how we behaved when faced with mystery. Maybe that's always been the test, not whether we can solve the puzzle, but whether we can look into the vastness without flinching, without turning it into fear. Somewhere, as the last traces of the comet faded beyond Neptune's shadow, a scientist wrote in her journal, "We thought we were studying it. But perhaps, all along, it was studying us, measuring the limits of our patience, our honesty, our faith in one another." That thought lingered. It still does. Because even as the world returned to normal, that sense of being observed by something greater, or perhaps by our own conscience, never quite faded. It remained, like an echo, waiting for the next time the sky changed. And soon, it would. For in the months that followed, whispers began to surface, from deep space monitoring stations, faint anomalies, new signals, a possible fourth traveler stirring beyond the heliopause. No confirmation, no statement, just data too consistent to ignore. And in that moment, the question that had haunted every silence returned once more, sharper, brighter, inevitable. If this next visitor was not chance, if the pattern was real, then perhaps the story of 3i Atlas had never been about discovery at all. Perhaps it had been preparation for what comes when the watchers finally step into the light.